So let's dive right into. And of course, you've already guessed it, we wouldn't be here if you couldn't set up NSO on Kubernetes, but let's just snack up a few points that might be interesting to those of you who have not worked with Kubernetes before. So we do offer a pre-built container image that's available on software.cisco.com. But of course, if that doesn't fit your need and you'd rather have like a different operating system, you want a different file structure, you have other software that is important to you that you want to have baked into your image, you can just go ahead, you build your own image, and you spin that up on Kubernetes. From a functionality perspective, spinning the container up on Kubernetes is not any different from any other container-based deployment, or if you were to deploy this just traditionally on a server. What I've found super nice when I started working with Kubernetes was that it turned out to be actually relatively simple to deploy NSO on Kubernetes. However, there's a couple of things you should keep in mind. So when people generally think about Kubernetes, they think that they automatically get this scaling that Kubernetes provides. And that is, yes, something that Kubernetes has to offer. However, your software application has to be built for that. And NSO is and remains a monolithic application. So this is one of the things you unfortunately will not get when you use NSO on Kubernetes. But well, let's move on to the actual example setup. So what I did in my setup, I used some YAML manifests, and they are just simple file definitions that will help to get a consistent outcome. And on the right-hand side, you will see some of these concepts that I used in my example setup, things like namespaces, load balancer services, persistent volumes, and so on. And so we'll talk through these concepts by looking at concepts that you're probably very familiar with and drawing some analogies to these familiar concepts. And the first one I would like to talk about is the concept of namespaces. So think about a namespace as a house or an apartment, something that you own, it is yours, it comes with rooms that are sort of equivalent to pods. You have storage in your house. There are other resources that belong to your house. Similarly, you have your neighbor on the other side. They have their own house, they have their own rooms, they have their own resources. You can't just go over there and use their resources, make yourself breakfast. It just doesn't work. On the other hand, you also get some other perks, like if your neighbor ties up the bathroom for 3 hours, well, it's not of your concern because it's not your resource that's being tied up. And that's exactly the concept of namespaces in Kubernetes. We get this logical separation of resources. So you can see that on the picture in the right-hand side here. And on the left-hand side, we see our very simple YAML manifest that says nothing but, well, we want to create an object of type namespace, and we need to give that object a name. And in our case, it's going to be called Cisco NSO. Another concept you're hopefully very familiar with that you might find in your own home, a lot of people have pin boards somewhere located in their home. Some people like to tape notes to their refrigerator with information that sort of concerns everybody that lives in the household. Maybe something like a trash schedule or something, or your kid's school schedule. So again, is it something that is sort of information that's publicly accessible and relevant to everybody in your home? In terms of NSO and Kubernetes, we find that the NCS config file actually lends itself to be put in a config map because it defines how our NSO environment or the NSO setup is supposed to behave. Like what kind of logging level do we have? What kind of APIs do we want to have available? So this is just kind of nice to be put into a config map. And on the right-hand side, you can see how that would look with such a YAML manifest. Once again, we have to define the fact that this is going to live in our Cisco NSO namespace. We have to give our config map a name. In my case, I called it NSO config. We're told Kubernetes that this is going to be a config map. And finally, we have a key value pair, the key being ncs.conf and the value being everything that is in the ncs.conf file. The next subject is going to be storage, and that's something you always have in your house. You have closets, you have cabinets, there might be dressers, chest drawers, and so on. It's for items that you want to use later on or that you just want to store away. And that concept is very important in Kubernetes as well, because by default, when you spin up a pod, it comes up just the way the image was defined. If you make any changes to it and then you restart the pod later on, those changes will be gone. And that's why we need this persistent volume. And so the way we can use persistent volumes is by having a persistent volume claim in our pod. That persistent volume claim refers to a storage class, and there's different types of storage classes. There's things like dynamic storage, there's manually allocated storage, and you have other things defined like the size. So there's a lot of things also dependent on the environment you're in. It's like depending on who the provider is for your Kubernetes cluster, you may have different types like file-based storage, block-based storage. But these are generally things you don't have to worry about once you're working with the environment itself. You set that up previously, and then you can just leverage it down the road. So, but before we're going to look at the actual manifest that uses a persistent volume, we're going to talk about another concept, and that is the concept of a stateful set. And the picture you see here is a blueprint of a home. And that's very much how stateful sets are. So the idea of a blueprint is that it very much outlines in great detail how something is going to look like. What is the size of the room going to be? Where are different rooms going to be located? Where are the electrical connections in the house? Where is my plumbing? And so on. So I can essentially take this blueprint and I can hire a contractor and I can say, build me this home. And the outcome should look exactly like the blueprint. And then I can take that blueprint again and send it to another contractor and say, build me this home, or build me 5 more of these, and they all should look alike. And that is exactly what we're looking for, repeatable outcomes when we use a stateful set. It gives us, in Kubernetes terms, a stable network identity. So when the pod is restarted, it will come up with the same name. If it had a persistent volume mounted to it, it will mount that same persistent volume again, so we have that same data available to us. If we use the stateful set to create multiple objects in one go, we'll create these objects in the same order and we'll tear them down in the same order. So that is what you essentially get from the stateful set. That's the important part, repeatable outcomes. So let's tie some of these concepts together that we talked about. We'll look at the important sections of this YAML manifest. We'll start out in the center here where we sort of define our container. And what you see on top here is, of course, we need to give our container a name. And this is sort of more like a schema. So we use Cisco NSO, and the container is going to be named Cisco NSO plus some number afterwards. Then we, of course, need to define which image do we want to use to spin up this container, this pod. That is then followed by the fact if that image is not present, do we want to download it from some registry? Also, we obviously want to have some ports available to us, APIs like the Web UI or the CLI, and this is what this next section is about. So we're essentially declaring here, these are the ports that we want to use. What is important about it, just because they're declared here, that does not make them available to the outside world. There's some additional steps that we have to go through, and we'll see those in the upcoming slide, how we can actually make these ports available to other applications and to the outside world. The following section is then about environment variables, and those are very special in the sense that they are only for the provided container that we use, because it requires that we provide a username and a password when we spin up that particular image. That is then followed by another important section, the volume mount. So we've already talked about the fact that we have information that we want to persist. Things like our config map is kind of nice if that doesn't change when the container boots up again. And of course, our runtime directory is something we obviously want to keep when the pod restarts. So here we specify where in our image the bound paths are, and ncs-conf is located in the etc ncs.ncs.conf directory, and our runtime directory is nso run. Then let's move on to the right-hand side where we're actually referring over to these volumes that we are going to make available to the pod. And the first section is where we're referencing back to our config map that we created earlier. That is then followed by our volume claim for our persistent volume that will contain the runtime directory. And you can see here, it has the size specified for our persistent volume. What you don't see here is the storage class. And the reason being is that when I set this up, I use the default storage class. So Kubernetes will actually reference the default storage class unless I specify anything different, which I haven't. So this setup will just come up with the default storage class being used. So the next concept is the load balancer service, and this is one way to expose a service to the outside world. So you can think of it as a hallway in your home that gives you access to the various rooms you have. What is super nice about the load balancer service is that it's a very standard way, so it's rather simple to set that up. It also supports all traffic, but just as everything that has upsides, it also comes with some downsides. And unfortunately, that means in terms of the load balancer service that it doesn't provide any filtering or routing capabilities. And that in turn again means that for every application that you want to expose to the outside world, you have to create a separate load balancer object. And why is that important? Well, that is generally associated with extra cost in your cluster because you need extra objects. So you might want to keep that in mind. Nonetheless, it's a fantastic way to export or expose our CLI port. And so here is the YAML manifest that does that. Also, again, very simple. We specify in which namespace this lives in. We have to tell it that this is a type load balancer, it's a service, and then we have to give that a port mapping and tell it to which pod we're going to forward the traffic. So on our pod, we're forwarding the traffic to port 2024. We can have a one-to-one mapping for where the traffic comes in, but we obviously don't have to. So let's move on to the next concept. Let's assume in your house all the rooms have Ethernet connectivity. So there's a switch somewhere located centrally in your home, and that then facilitates communication for all these rooms. And Kubernetes has a very similar concept. It's just a service. It's called a service. And by default, that is of type cluster IP, which means that your pods can talk to each other. We're exposing services and applications. However, they're only exposed to the cluster itself. There is, at this point, no communication to the outside world. Another nice thing that we get from this is a stable IP address and a DNS, so it makes it a lot easier to communicate and find our pod and service to communicate with. So let's see how this looks when we have a YAML manifest. So here it looks very similar to a load balancer service by itself. Once again, we of course have to give it a name. We have to tell it that this exists in the Cisco NSO namespace. And then we again tell it where do we forward our traffic to. It needs to be forwarded to our Cisco NSO pod. And we do have our port mapping on the pod. The target port is 8080 because now we want to make our web UI available. And the traffic coming in is also going to be on port 8080. If you look at the picture now on the right-hand side, so you can see the service is sort of wedged in between there, an object that is called ingress and the NSO node. So in order to make this service available to the outside world, now we need an additional object, and that is that ingress object. So let's talk about how we can make the service now available to the outside world. Ingress is sort of like your front door to the cluster, where you can get exposure to the outside world. Ingress is a very powerful concept, and you get a lot of things that you didn't get with the load balancer service. So think back to that the load balancer service doesn't provide any filtering and routing capabilities. Well, our ingress service, on the other hand, it has subdomain-based routing and path-based routing that it can make available. What that means is that we can just have a single ingress object in front of a lot of services that can then send the traffic to the right pod where we want this traffic to be sent to and processed. So additionally to ingress, you have a choice of various different ingress controllers. In the setup that I used the Nginx controller. You can then jazz that further up if you want to use additional plugins that environments have available. And there's, for example, things like TLS certificate managers. So those can be used and they'll create a TLS certificate for you, and they manage the life cycle of the certificate. So when the certificate expires, it will automatically renew it. So I think you can already see that the concept of ingress is very powerful. Unfortunately, everything that is very powerful often means that it is also somewhat more complex to set up. And so you can certainly get into a rather complex setup. Luckily for us, we're only looking to explore port 8080, and that still is relatively simple. And this is how it looks like. So on the left-hand side here, we have our YAML manifest, and we just specify the fact that yes, we want to use an Nginx controller, and all our traffic that's being sent to that host, we're looking at the prefix. We're doing some prefix matching here, but in our case, we're matching everything. So that just means all traffic that is coming in, we're take that and we're sending it on to our service that sits behind it. This is what we just created before, the Cisco NSO service, and we send it on to the service on port 8080. On the right-hand side in the picture, you can see this concept of that you can use a single object to do then path-based routing or subdomain-based routing to then send your traffic to the various services and the pods behind them. So, and voila, now we actually have a setup that is usable. So I think this is sort of a nice example of how you can use NSO and very quickly get to a replicable and workable setup for NSO, something you can play around with if you haven't used Kubernetes. Just keep in mind, this is not production ready the way it is. So if you want to use this in production, there's a couple of things you should want to tweak. If you remember, we talked about the concept of config maps. Well, there's certain information that you do want the pod to be able to access, but maybe it shouldn't be readily accessible. So there is a very similar concept that's called secrets. So that is something that you might want to look into if you think about taking this to a production level. But in general, the setup the way it is, I think it's great for just for testing, to play around with, see if Kubernetes is something that you want to use in your environment. Well, and with that, thank you so much for listening, and I hand the talking stick back over to John.
Thanks, Rebecca. And actually, we'll chat here for a couple minutes yet, because we have a little bit of time here for Q&A, and we've got a couple of questions to pick your brain on here. So first off, it's kind of, I have two kind of related questions. So let me ask both of them, and I'll let you either answer them together or separately. But one question was about just what are the key benefits of deploying NSO on Kubernetes compared to a traditional server-based deployment, and the related question is what are the use cases for NSO on Kubernetes? So kind of two takes on almost the same question. So
Okay, well, so when you talk about key benefits of NSO on Kubernetes, what I really found very nice when I started working with Kubernetes and started looking into this project was that I found that it was rather easy to set up. So what it really does, it simplifies deployment and management. So the deployment process, as you can see, you can use this YAML manifest, and you can create one of those manifests for your different objects, and you can kind of match them together depending on how you want your setup to look like. So, you can build a very simplistic base container, so to speak, and then depending on what kind of config map you have the pod reference, what kind of runtime directory do I want to mount, you have a lot of flexibility. And that is something that I really see as the key benefit when someone would use Kubernetes to deploy NSO. Of course, if you would hard press me for an answer, is Kubernetes better than a traditional deployment? I would say, well, possibly, but most likely depends on the use case, because everything has upsides and downsides. So with everything that Kubernetes brings, there's also challenges. So you'll have challenges in a traditional setup, you have challenges in a Kubernetes deployment, but they can be very, very different. So it depends. If you would ask me about a use case, so because you have so many different objects that you can sort of pick and choose and how to put them together, I think that Kubernetes and NSO on Kubernetes is really great to use in a test environment, because you can spin those containers up very quickly. You can change the config on it very quickly just by mounting a different config map to it. And that's where I think this is really a great use case. Just do your testing with Kubernetes and NSO on Kubernetes. Set up a pipeline for testing and use it there. So I hope that answered the question.
okay, great. And we got just a slight bit of time here left, but let me try and quick squeeze in a couple questions if I can. They're kind of similar, but when would someone want to use config maps instead of just keeping the config data on persistent volumes?
Well, I think I already kind of alluded to the fact that you have this opportunity to piece parts together the way you need them. So the nice thing about a config map is obviously that you can store environmental variables in there, like something like our ncs.conf file, where we can change how NSO is going to behave. So we can open different APIs, we can set our logging level and so on. So that makes the whole setup very flexible. And when you have flexibility, that in case of Kubernetes, that also means you have portability. So you can very quickly adapt your container to a different environment just by mounting a different config map to suit your new environment where the container is being brought up.
Thank you, Rebecca, for that insight. And if anybody has any additional follow-ups on topics, I'll just remind you of our developer hub community on DevNet, where you can interact with all of our experts here at Cisco as well as other members of the community.